Okay, the next thing we're going to do is instead of solving by graphing, we're going to solve by combination slash elimination. Now, I still have two equations, one here, one here. And we're still going to use those linear equations. Now, I could go to all the trouble to get y by itself and graph it, and y by itself and graph it. But if you remember, the reason we don't like graphing as a method, as a general rule, it's not because we don't like graphing or because it takes so long. It's because it's going to be inaccurate. What we want to do is we want to find a different method that is guaranteed to give us a more accurate answer every time. Now, in this case, we're going to do what's called the combination or elimination method. And the reason it has two names is because we're really going to do two things. We're going to take this equation here, and we're going to take this equation here, and we're going to combine them. Now, the goal is, if I combine two equations, if I try to say, for example, add these two up, 8x take away negative 5x, take away 5x is 3x, and negative 4y and negative 5y is negative 9y, and I get 21. And I'm not really any better off than when I started because I still have an x, I still have a y, and I still have a number. But if I were to go over to this problem over here and do the same trick, I'm going to add them up. Well, 30 plus negative 18 as well, that's going to be 12, okay, equals now 5y, and we say minus a y because we're adding, so 5y plus negative y is 4y. But look what happens over here with the 3x and the negative 3x. The 3x and the negative 3x cancel out, and so they are eliminated. By combining them, we eliminated one of the variables. The nice thing is, hopefully at this point, everybody can see how to find y. Well, divide by 4, y equals 3, and there you go. Now you say, well, great, I'm done. No, because remember, when two lines cross, if they cross at a point, there is an x part and a y part. So we not only need to find the y part of the solution, we need to find the x part. But at this point, it's no big problem, because if y equals 3, pick an equation, top or bottom, makes no difference. Bottom. I'm going to take the bottom equation, negative 3x minus something equals negative 18. I'm going to take this y that is a 3, I already know it now, I'm going to plug it right in. And if I do that, I now have 1x that I can solve for. So I'm going to add 3. Negative 3x equals negative 15. Divide both sides by negative 3. X equals 5. If x equals 5, now I know that they cross at 5, 3. And that is my solution. And they have one solution. So by combining these two using simple addition, I eliminated one of the variables, able to solve for that the other variable, then plug it back in to find the answer. Now, let's go back over here to this one. It would be nice if I could do this problem in a similar way. The problem is we already determined that if I try putting these together, nothing goes away. And so if nothing goes away, it doesn't help me. However, is there a way I could change one of these to get rid of one of the others? Now over here I needed a positive version of a number 3 and a negative version of a number negative 3 to get rid of them. So what would I multiply this by and multiply this by that I could get rid of an 8 and a 5? Well, the easiest thing that an 8 and a 5 go into is 40. So if I multiply the top by 5, but if I do it to one side, I must do it to the other. So I come up with 40x minus 20y, and 5 would be 80. So I put 80 over here. Now, on the bottom, how do I get negative 5 to be something that would go away with 40? Well, if I multiply by positive 8, I come up with negative 40x and negative 40y equals, looks like 40. So now, by multiplying something by the top and by the bottom wisely to get one of these two terms the same, when I go to add them up, that cancels that. I get negative 60y equals 120. If that's the case, now again, it's very easy. Divide by negative 60. y equals -2. If y equals -2, then all I have to do is plug it right back into one of the equations. Now, last time we chose the second one. This time I'm going to go back up and I'm going to choose the top one. 8x minus 4 times something equals 16. Now, I leave the something open to show that what do? I plug in that -2. So I have 8x, now negative and negative make a plus 8 equals 16, minus 8 minus 8. And so 8x equals 8, x equals 1. So my solution would be these two pieces right here, 1 comma -2. 1 comma -2. Now, in this case, we've done combination on this, but instead of just being able to add them together directly, we actually had to do something first to this over here before I could do something else to the other side. But then once I did it, something crossed out, and it worked out very, very nicely. Here's what I want you to do. I want you to attempt to do the following problem. Let's go y equals 6x plus 6, y equals 3x plus 6, and that's problem number 1. Let's do a -3x plus 4y equals 24, and 4x minus y equals 7. That's number 2. And then let's do a third one here. Let's do 2x plus 3y equals 10, and 4x plus 6y equals 12. Okay, take a look at those three problems, and we'll see how it goes. Make sure those are done for tomorrow.